So in this video we want to walk through the process of deriving the antiderivative formula for a base A exponential function. So the claim is that the antiderivative of a to the dx is just equal to a to the x over the natural log of base A plus a constant of integration. And the way that we can get this formula for the antiderivative of a base A exponential function is by starting with our definition or formula for the derivative of a base A exponential function, which a formula which we actually developed from scratch in a previous video. So if we start with the idea that the derivative d dx of base A to the x is equal to the natural log of base A times a to the x. The first step in developing this formula is just going to be to take this relationship or identity and say, hey, we're going to integrate both sides with respect to dx. And the idea is if we integrate a derivative, we're going to get back our function a to the x, because the antiderivative will cancel the derivative within a constant of integration. So if we take the derivative of a to the x plus c, we'll get back what we started with within a constant. And so this is going to equal, we have the antiderivative of the natural log of a times a to the x dx. And what we want to recognize here is that the natural log of a is just a constant. It's just a real number. And because it's just a real number and doesn't have a variable, it can be factored out of the integration or summation that's happening when we take an antiderivative. And then when I look at this, I want to recognize now that I could multiply both sides by 1 over the natural log of a. And if I do that, I would be dividing everything on the left-hand side by the natural log of a. And if we do that, the natural log of a divided by the natural log of a is just equal to 1. So we get the antiderivative of a to the x dx, which is what we're trying to find. That's right here. That's what we're trying to find. And here I have the a to the x over the natural log of a. And all we need to recognize here is when we integrate and we get that constant of integration, let's subscript it with a 1. We'll call it constant of integration 1. So here I have a constant of integration divided by the constant natural log of a. But if you divide two constants, you just get another constant. I'll call it c sub 2. And then by convention, we'll drop the subscripting off of it. So there we have the formula for the antiderivative of a to the x dx. It equals a to the x over the natural log of a plus a constant of integration.